Okay, let's take a few minutes and discuss vector resolution. When we're talking about the process of vector resolution or resolving a vector, what we're doing is we're breaking it down into perpendicular components. So let's take a moment to look at this. If we have a vector at some angle theta that is a size r, what we will do is we're going to break it down into horizontal and vertical components. Okay? It's written this way in what we call polar, or sometimes called r theta notation, where r is its magnitude and theta is a direction, it's an angle. We need to convert that into something called component form, which is oftentimes an XY or an XYZ form. Now we will do this and we will have something that is some X in the I hat direction, talk about that in just a second, Y in the J hat, and Z in the K hat direction when we need 3 dimensions, and then comma unit. So what we're having are these things that I just mentioned called I hat, J hat, and K hat. These are called unit vectors. Unit means it's size 1, and they correspond to the X, Y, and Z directions. Component form makes things such as vector addition much simpler. In this example, 14 unit vector at an angle of 45 degrees. So we have 14, we have our X, we have our Y. From basic right triangle trig, we know that the sine of theta is opposite, which is the y, over the hypotenuse, which is the 14, and cosine of this is 45 degrees. Let me change that. And cosine of 45 degrees, which is x over our hypotenuse, which is our 14. Since in both cases sine and cosine of 45 degrees is 0.7071, we end up with 0.7071 is equal to y over 14, and 0.7071 is equal to x over 14. So both of these end up being the same thing, which is approximately y equals 9.899 and x equals 9.899. Now, angles are a bit of a problem when it comes to significant digits. What I will typically tell you is carry at least 3. Often I will carry 4 values past the decimal place when working with trig values, the value of a trigonometric function. But take your significant digits from your other units in the problem. Don't worry about the angles. So in this case we need 2 significant digits. So the x would then be 9.9 and the y would also be 9.9. And so this vector would be 9.9i plus 9.9j. If you needed to write it in 3 dimensions, it would be 0k, and then comma, then your unit, which in this case I just left as unit. So in this example, a child pulls down a window shade with a force of 30 newtons. Now don't worry yet about what newtons are, but they're just some unit of measure. There's 20 degrees. We need, in this case, our x and our y components. From right triangle trig, in this case, y is going to be equal to 30 sine of 20 degrees and x is going to be equal to, cosine of 20 degrees, and x is going to be equal to 30 sine of 20 degrees. That's a COS, not a CUS. So the sine of 20 degrees is approximately 0.3420. Excuse me. The sine of 20 degrees is approximately 0.3420. The cosine of 20 degrees is approximately 0.9397. So this is about 28.19. This is about 10.26. Now again, we're not going to pay any attention to the digits in the angle, but we are going to look at our others. So this is 3 significant digits. So when we're writing this, we're going to have approximately 10.3 I plus 28.2 J newtons N. A quick check is simply to use the Pythagorean theorem. 10.3 squared plus 28. That should be 2 squared equals, and then you take the square root of that, and you get 30.02, which with rounding is the same answer we started with. When we're adding vectors, if it's one dimension, it's not too bad, because we end up with, in this case, 80, and since this is a positive, I'm going to say it's to the right, 80 miles per hour. A headwind means it's in the opposite direction, plus a negative 10 miles per hour, which is going to be a total of 70 miles per hour. If it's a tailwind, that means it's pushing on the back of the plane. So we have a resultant of 90 miles per hour. C. If it's a crosswind, so if we have 80, and it really doesn't matter for this problem which way our crosswind's going, in 10, we can find the magnitude of our resultant simply by using the Pythagorean theorem. 80 squared plus 10 squared is equal to r squared. So 80 squared is 6,400. Plus 100 is r squared. 6,500 is r squared. So r is about 80.62. Now in this one, we're not going to pay a whole lot of attention to the significant digits because our values are only one digit. And while we could, that would leave us with an 80 here. If we needed to find the angle, then we're simply going to use, I'm going to use tangent of the angle, theta, is opposite, which is 10, over the adjacent, which is 80. So that gives me an angle of 7. Which is going to give us approximately 7.4 0.13 degrees. Again, we're being a little fast and loose with our angles and our significant digits. For part D, we now have a 60 mile per hour crosswind. So that we have an 80. We still have our crosswind in the same direction, but now it's much larger. Still doing Pythagorean to find out what the magnitude of our resultant is. It's an R. So I have 6,400 plus 3,600 is R squared. That's going to give me 10,000 is R squared. Well, just double checking myself. So 100 is R. And my angle, still using tangent, but in this case it's 60 over 80. So my angle is going to be much larger this time. It's going to be about 36.9 degrees.